For the following functions, find when it is concave up, concave down. Oh, and I forgot to mention, this point here where it switches concavity, that's called an inflection point. It's also what boys experience during puberty. It's terrible. Part A! F of x is x cubed plus 5x squared plus 8x minus 6. So we're going right to concavity. So to find concavity, we need to find the second derivative. To find the second derivative, we first need the first derivative. What is the first derivative? 3x squared plus 10x plus 8. So pray tell, what is the second derivative? 6x plus 10. So we take our 6x plus 10. We see where the derivative is 0. We see where it does not exist. We can take care of the does not exist portion of the show because it's a polynomial, and it always exists, so nothing to worry about there. So if you set 6x plus 10 equals 0, and you solve for x, what do you got? Are people using calculators? Are using calculators. Negative 5/3. So we draw a number line with our negative 5/3. So again, exact same stuff as the first derivative, except now we're going to talk about concavity. So negative 5/3 is what? Negative 1.6 repeating. So give me a number less than that. Negative 2. Give me a number bigger than that. You're going to put in negative 2 and 0 into the, which is the second derivative, because we're finding out about concavity. So I do suggest that you make a little list here. Actually write the F double prime there to remind you, hey, we're doing concavity. So if you put negative 2 in for the 6x plus 10, you get negative 0, positive. So notice to the left of negative 5/3, the second derivative is negative, which means the function is concave down. Concave down. From negative infinity to negative 5/3. And to the right of negative 5/3, the second derivative is positive, which means the function is concave up. And notice the signs change around negative 5/3. So it's an inflection point because what else do we have to check? The domain, is it in the domain? Yeah, it's a polynomial, so it's in the domain. So we have an inflection point. I'm going to write that here. At negative 5/3, comma. How do we find the y-coordinate of the inflection points? Put it in the original function. So you're going to put negative 5/3 back into our cubic. It's not a pretty number. So what I suggest you do is use your calculator and do a math convert to fraction command. You got negative. Your calculator may be rounding to 1 decimal place, because this should be a fraction. Like a sixth or something? Well, I don't know what do you get? I'm sorry? No, I don't. No, it should have a denominator of a 6 or something. No, it has a denominator. You have 27. Does anyone have a 27? Negative 272 divided by 27? Anyone? Anyone? Bueller? Negative 272 over 27. Negative 10 point something. Part A. Part B. 1 over x. We'll have to put part C on its own thing, so I'll have to erase this when we're done. Okay. Now, 1 over x is currently a fraction. It's a basic fraction. If you don't want to have to use the quotient rule twice, because we're going to have to do 2 derivatives, how can you rewrite 1 over x? X to the negative 1. So notice I did not put a prime on this yet, because I did not take the derivative. So by writing it as x to the negative 1, we can just use the power rule twice. What's the first derivative? And what's the second derivative? 2x to the negative 3. And rewriting this back as a fraction, which makes the rest of the problem easier, what do we get? 2 over x to the third. Very good. So we have our 2 steps. We have to see where the derivative equals 0 and see where it does not exist. Where does the second derivative equal 0? Never, because when a fraction equals 0, the numerator equals 0. Does 2 equal 0? Not today. Nothing. How about when does the second derivative not exist? 0. because that makes the denominator 0. That's bad. Now what do? Number line. Give me a number to the left of 0. Negative. Oh, wait, I need a different color. We're going orange. I need you to go away. Thank you. Right of 0. Where am I putting these two numbers? Into the second derivative. What is 2 over the quantity of negative 1 cubed? You're killing me, people. Negative 1 cubed is negative 1, and 2 divided by negative 1 is negative 2. 2 divided by 1 cubed, 2, which is positive. Awesome. So, to the left of 0, the function is concave down from negative infinity to 0. To the right of 0, the function is concave up. And at 0, we have a wah, wah. We don't, because is 0 in the domain of the original function? No. What do we really have at 0? No. Which one? Vertical asymptotes. So with your rational functions, the ones that are fractions, because everyone remembers chapter 10, we have a vertical asymptotes. No matter how hard you pinch yourself, you will not wake up from this nightmare. Part C. H of x is e to the x, oh my gosh, plus x squared. Oh, it's amazing. I have to erase part A over here. So what I want you to do is, while I'm erasing, figure out what the first two derivatives are. What's the first derivative? E to the x plus 2x. What's the second derivative? Alright. This one's icky. It's going to be okay. We have to see where the second derivative is 0. And we also have to see where the second derivative does not exist. Well, remember, it's an exponential function, so we can take care of this does not exist really quick, because what's the domain of an exponential function? Oh, reals. So for the right-hand column there, we would say there aren't any values for x that would make it not exist. And over here, if we set e to the x plus 2 equal to 0, that means e to the x is negative 2. Well, we can go back to what we did in chapter 10, where we wrote this as a logarithm, but we'd be taking the log of a negative number. Can you take the log of a negative number? By the sound of my voice, no, you can't. It will not exist. Another way to explain it is e is a number. E is 2.8. I forgot what it is now. So if you're raising 2.8 to a power, is that ever going to equal something negative? No, no matter what the power is. So what values of x do we have here? None. So notice we have no critical values for the second derivative. What's a girl to do? You pick any number you want. Pick a number. 0 it is. Notice I'm not picking numbers around 0. I'm picking 0 itself. So 0 is our only test number. It's actually a test number, not a critical number. So if you put 0 into the second derivative, what's e to the 0 plus 2 without a calculator? 3. 3 is positive. So no matter what number you pick for x, you're always going to get the second derivative to be positive. So what does that say about the concavity? It's concave up. So where are we concave up? Everywhere. Negative infinity to positive infinity. So again, 0 was a test value, not a critical number. In fact, I should use a dot, not a tick mark there. I'll make it a big one. There you go. That looks pretty.